Is it? Yes, it's recording. Okay.
Yeah.
So, we have 3 steps to doing these first 3 problems. It says verify that the function has an inverse. These are not going to be trick questions. They're not going to tell you to verify that it does have an inverse if it doesn't have an inverse. Okay, they're just trying to get you in the mindset that maybe not every problem has an inverse. Also, find the derivative of the inverse. This is the formula for the derivative of the inverse. Sort of like when we learn the chain rule, this formula doesn't make a ton of sense until you actually get in there and do it, and then you figure out that it's actually a lot easier than what this looks like. But technically it is that the derivative of, say, the inverse function, okay, because it's saying f and g are inverse functions of each other, so the derivative of the inverse function is going to be 1 divided by the derivative of the original function with the y-coordinate plugged in, is what that means. You know how you've got x f of x or x g of x. The g of x represents the y-coordinate from the inverse. Okay? Now, the y-coordinate from the inverse is the same as the x-coordinate from the original point because we switch x and y when we find derivatives. So we're going to, I don't expect that all to be crystal clear at this point. We'll get into the specifics as we work some examples. Now, we need to find the equation of the tangent line to the inverse at the given point. So our final answer will be point-slope form. Y minus y1 equals m times x minus x1 for the inverse function. Okay, and we're not given the inverse function. We're given the original function, but we are given a point on the inverse function. So how are we going to do this? We're going to make a little chart that says inverse and function for each problem. So if my point on my inverse is 9, 3, I'm going to write that underneath inverse. So what would be the corresponding point on the original function? 3, 9. Very good, because we switch x and y when we do inverses, right? So this is what I want to do. I want to find f prime of 3. Okay? So they give me the original f function. I'm going to take its derivative. And notice they have restricted the domain here to x is greater than or equal to 0. That's because the function is the parabola parent function. Would that pass a horizontal line test? No. A horizontal line would hit this function twice in places, which means no inverse. But since they've restricted the domain, we do have an inverse now. Okay? So I'm going to take the derivative f prime of x. The derivative of x squared, of course, would be 2x. Good. And then I'm going to evaluate that inverse when x is 3. So f prime of 3 would be 2 times 3, which is 6. Okay? So the relationship between the derivative of the inverse at this point and the original function at its corresponding point is that they are reciprocals of each other. So f inverse prime of 9 will equal 1/6. Now I want you to think about this. If I were to graph the original function x squared, and then what is the inverse of x squared?
2x. Sorry.
No, not the derivative, the inverse.
Square root.
Square root of x, right? Square root of x. In the same window, they are reflections of each other across the line y equals x. The slope is positive on this one. The slope is also positive on this one, but this one's flatter, isn't it? This one's steeper, okay? So we got 2 positive slopes, just the original function is steep, and the new one, the square root one, is flatter. Does that make sense? Yes?
Could you just zoom in just a little bit?
Oh, of course. Yes. I will zoom in. No problem. All right, so we did find the derivative of the inverse at this given point, and now we're going to write the equation of the tangent line. We have a point, we have a slope, so we use those in the tangent line equation. Y minus y1, which would be 3 on the inverse, equals the slope of the inverse, 1/6, times, bless you, x minus 9, which is the x coordinate on the inverse. And that's our answer to this problem.
So we're just finding the equation, we're not answering it?
We are finding the equation of the inverse to the tangent function at that given point.
Yeah, that's what I meant.
Yes.
I don't understand, how did you get 1/6 of 9?
Because of this rule, all right, we have an inverse point and we have a function point. They are switched, x and y from each other. If you find the derivative of the original function, then when you flip the x and the y, the derivative of the inverse function will be the reciprocal. And this is a note card that's going to be in your stack that you will have to have memorized.
So if the derivative or whatever is like 7, then the inverse would be 1/7.
1/7, we go with 7, yes. Any other questions on that first example? Okay, let's take a look at the next one. We're going to do the same thing. We have a place for information about the inverse and a place for information about the function. So, they give me a point on the inverse. That point is 3, 2. What is the corresponding point on the original function? 2, 3. So now I want to figure out what f prime of 2 equals. So I'm taking the x coordinate of the function point and plugging it into the derivative for the original function. They gave me the original function, so I'm going to take its derivative. F prime of x equals. What's the derivative of this cubic function?
3/4 of x
Plus 1.
squared plus 1.
Very good. 3/4 x squared plus 1. Now we're going to substitute a 2 in for the x in that derivative. So f prime of 2 equals 3/4 of 2 squared plus 1. So that's 4. 3/4 of 4 is 3 plus 1 more equals 4. So this is 4. So now I want to know what is the derivative of the inverse function when we're at 3 on the inverse function.
Yes, 1/4.
That is correct. It'll be the reciprocal of this number. It will be 1/4. And now we're ready to write the equation of the tangent line. Y minus, we're on the inverse, 2 equals
1/4
1/4 times,
times x minus 3.
very good. Any questions? All right, the next one, number 3. Again, we're going to start by setting up what do we know about the inverse and what do we know about the original function. They gave us a point on the inverse. The point is 3, 6. What is the point on the original function? 6, 3. So we're going to calculate f prime of 6. So that means I have to take the derivative of this rational function. How would I take that derivative? Quotient rule. So I'm going to start with the denominator, x minus 2. I'm going to multiply it by the derivative of the numerator, which is, very good, minus, I'm going to copy the numerator and then multiply it by the derivative of the denominator, which is 1, all divided by the denominator squared. Very good. Okay. let's see if we could simplify this a little bit, because I'm seeing this negative distribute, right? So I have a plus x here and a minus x here. The x's will go away in the numerator. And then I have a minus 2 and then minus 6. So those will add up to negative 8 over x minus 2 squared. So now I'm going to substitute 6 in for the x. F prime of 6 equals negative 8 over 6 minus 2 squared. So negative 8 over 4 squared is 16. Negative 8 sixteenths would equal negative 1/2. Negative 1/2 is the derivative of the function at 6. So what is the derivative of the inverse at 3? Negative 2. So now I'm ready to write my equation of the tangent line. Y minus 6 could equals negative 2 times x minus 3. Very good. That's the answer.
How do you know which one to use again for your f to the negative 1 prime of y? How do you know which
It's
one is it?
the x coordinate of the inverse or the y coordinate of the function.
Got it.
Okay? Goes inside as the value for the independent variable on the inverse function's derivative. Any other questions? All right. Now let's get into some that don't even give you a function. Number 4, let f and g be functions that are differentiable everywhere. If g is the inverse function of f, all right, I'm going to write this down. Inverse has a name. It's g. And the original function has the name f. That way I'll remember which is which. Okay? And if g of negative 2 equals 5, what is this telling me? G of negative 2 equals 5. The point on the inverse, that's right. So the coordinates would be negative 2, 5. So what is the corresponding point on the original function? 5, negative 2. Good. Now it tells us f prime of 5 is equal to negative 1/2. So that goes over here, right? This is about the f function. F prime of 5 equals negative 1/2. They want us to find g prime of negative 2. It is just negative 2. It's the reciprocal of this one. The answer is negative 2. There's really no math to do here other than making sure you identify what is what and knowing the relationship between the derivative of the original function and the inverse at their corresponding points, that those are reciprocals of each other. Okay? Questions? All right, number 5 is a calculator problem. It says, let f of x equal x cubed minus 7x squared plus 25x minus 39, and let g be the inverse function of f. So I'm going to say the inverse is g, and the original function is f. They want us to figure out what is the value of g prime of 0. G prime of 0 equals what? That's what we have to figure out. They didn't give us any points. So this 0 belongs where in the inverse point?
X.
It's the x of the inverse point, which means where does it belong in the original function? It's the y of the original function. Well, we actually do have a function here. So if I set that function equal to 0 as like the y equals for it, then I can solve for x. And that's why this one is a calculator problem, because they don't want you to solve that by hand. They want you to use the calculator to solve that. So I'm going to say 0 equals x cubed minus 7x squared plus 25x minus 39. And I'm going to go in my calculator, and I'm going to go to y equals, and I'm going to type that in. X cubed minus 7x squared plus 25x minus 39. And I'm going to graph it. I'm looking for what x value would make this function equal 0. Or in other words, where does it intersect the x-axis, because that would be y equals 0, right? So I'm looking for the zeros. Now it kind of looks to me like it hits at 3, just eyeballing it. What do you think? Looks like 3. So let's go to the table. 3, 0 is an actual point on this function, okay? If I didn't get it at an exact answer, I could hit second and the calc button and choose option 2 for 0 and go left bound. So there I'm on the left side of the 0, hit enter. Arrow to the right side of the 0, press enter. Press enter when it asks for a yes, and it gives me the 0 is at 3, 0. Okay? So x equals 3. Second and the trace button for the calculate menu to 0. And you have to arrow to the left and the right and press enter after each one to tell it where to look, because there could be multiple zeros and it can only find one at a time. Alright, so we have the x coordinate is 3 on this function when y is 0. So the 3 would also go here in my inverse. So now I want to know what is f prime of 3. So I need to take the derivative of this function, f prime of x, which will be 3x squared minus 14x plus 25, and substitute 3 in there. Or, since this is a calculator problem, I could do this in my calculator. I could go to my home screen, and I could hit alpha window, option 3 for derivative. Y'all remember doing this earlier this year. ddx. My function's already typed in y1, so if I hit alpha trace number 1, it'll pull that in there, such that x is 3, and it gives me 10.
Oh, we get alpha trace, like...
Alpha trace enter will pull the y1 into that parentheses, so you don't have to retype it. You could retype it, but that saves you a little bit of button pushing. So I get f prime of 3 is 10. So what is g prime of 0? 1/10. And that's the answer to this problem. Any questions? All right. Number 6. This one is a little bit more work, more like old school kind of stuff. If f of x is equal to x, and I don't know if y'all can see that clearly on your paper, that's to the power of negative 1/3. The negative kind of blended in with the division bar a little bit. What is the derivative of the inverse of f of x? This is not at a specific point, so we're not going to have a numerical answer. They actually want us to write the function of the derivative of the inverse. So for this problem, we're actually going to have to switch x and y, find the inverse, and then take its derivative. Now, they're not going to give you one like number 5 to do that on, okay? It's going to be a simpler one like this. There's just one x, there's one y. It's kind of more doable, okay? So we're going to say x equals y to the negative 1/3 power. I just switched the x and the y. Now I want to isolate y. How do I get rid of a negative 1/3 power?
You make it a cube root, a negative cube root.
Well, that is a cube root already.
Multiply by cube root of y.
The natural log.
Wait, no.
You cube that. Cube both sides.
Close. Not quite.
Cube y both sides.
Negative cube.
Negative cube both sides. Because when you raise a power to a power, you multiply the powers. And we want this power to be 1, right? So negative 1/3 times negative 3 gives us a power of 1. So I'm going to raise this side to negative 3 power as well. So x to the negative 3rd power equals y. That's the inverse function. Now I need to find the derivative of the inverse function. So if y is equal to x to the negative 3, y prime would be, we'd use the power rule to take the negative
3x to the negative 4th power.
negative 3x to the negative 4th power. That's right. And that's probably not the way the answer would look on a multiple choice question because of the negative exponent. So you might have to change it to y equals negative 3 over x to the positive 4th power. But that's the answer on this one. Do y'all have any questions? Okay. Number 7. Let f and g be functions that are differentiable everywhere. If g is the inverse function of f, okay, I'm going to write that down. Inverse is g, the original function is f. And g of negative 3 equals 9. What is that telling me? Point on the inverse is negative 3, 9. Good. So what's the point on the original function that corresponds to it? 9, negative 3. Awesome. And f prime of 9, okay, that belongs under f. F prime of 9 equals negative 2/5. Find g prime of negative 3. Negative 5/2. You do the reciprocal of this one. Do you see how if all you had done all year were problems where you were given the function and then you read a problem like this on the AP exam, how it might seem kind of mind-boggling, like you didn't get enough information? But really, this problem's easier than the ones where they give you the function. There's less work to do. You just really have to understand the relationship between the pieces of the puzzle. Okay? All right. Number 8. Let f of x equal the sine of x for the domain x values from negative pi over 2 to positive pi over 2. Picture your unit circle. Where is the angle negative pi over 2 with respect to the origin? Directly below the origin is the angle negative pi over 2. And directly above the origin is positive pi over 2. So we're talking about like quadrant 4 and quadrant 1 of the unit circle. Those are the only ones we're working with here. And the sine is the y-coordinate. So like all the negatives for y would be in the 4th quadrant, and all of the positives for y would be in the 1st quadrant, right? So just, that's where we're looking. Let g be the inverse of f. So my inverse is g. My original function is f. What is the value of g prime of 1/2? Okay, g prime of 1/2 is what we're trying to find. Where does the 1/2 go in the coordinate pair for my inverse? That's the x of my inverse. So where does it go in the original function? The y. All right. So I need to figure out what the x is that goes with it by using my function. Okay. So 1/2 is the y. So I'm going to write 1/2 equals the sine of x. How do I get the sine off the x to solve for x? Inverse sine. That's right. Inverse sine of 1/2 equals inverse sine of sine of x. And that inverse sine cancels the sine. So that leaves me with x on the right. Now I need to think, at what angle on my unit circle is the y-coordinate, the sine value, equal to 1/2? That's a short one. It's positive. Not pi over 4, but you're close. Pi over 6. Huh? Yes, I will zoom in. It's pi over 6. That is correct.
Oh, no, but why did we cross out the two sin, the sine?
Inverse sine cancels a sine.
Okay.
So pi over 6 is the x-coordinate I was looking for my original function, which is the y-coordinate on my inverse function. So I need to figure out the value for f prime of pi over 6. So what is f prime of x equal to? Cosine x. Derivative of sine of x is equal to cosine of x. So now I need to know, what is f prime of pi over 6 going to equal? So what is the cosine of pi over 6? Square root of 3 over 2. Very good. Square root of 3 over 2. Now, what does that make the derivative of g at 1/2 equal? 2 over the square root of 3. That is correct. And I'm fine with you leaving your answer like that. However, that's not what they'll put in the options on the multiple choice problems, because they do rationalize the denominator when it's a constant, not anything with x. So if I were to multiply this times the square root of 3 over the square root of 3, what would that equal? 2 square root of 3 over 3. That's the answer you'd find in the multiple choice problems on the AP exam. Yes?
Why was it square root of 3 over 2, not square root of 2 over 2?
The cosine of pi over 4 is square root of 2 over 2. The cosine of pi over 6 is square root of 3 over 2. Any other questions?
So the inverse of sine is just cosine?
The derivative of sine.
No, the inverse of sine is inverse sine. We never found the inverse of the function.
Wait, but then where's cosine?
That's the derivative of the f of x function.
Oh, right.
Yes.
Can you explain the inverse sine 1/2 and how you got pi over 6?
Sure.
Think about it as if
Okay. If I'm on my unit circle, which I have a picture of in the front cover of my calculus book, what I'm saying is that if I'm looking from negative pi over 2 to positive pi over 2, where is the y-coordinate on the unit circle equal to 1/2? So I can see here is an x and a y. The y is 1/2, and the angle where that happens is pi over 6. Okay? So when we're saying inverse sine of 1/2, that's saying if the sine is 1/2, what is the angle that would go with it? Okay? Any other questions?
And if it was cosine, the inverse would be a different question, right?
The inverse cosine is usually set up from 0 to pi, because that's how you get all of your x values to be both positives and negative. Okay?
So all students take that.
All right. Number 9. Given y minus 4 is equal to 1/3 times the quantity x minus 1 is the equation of the tangent line of f inverse of x, the inverse function of x. Write the equation of the tangent line to the function f of x at x equals 4. That's a little bit of a blah, 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 blah kind of a reading here, isn't it? Let's see what we know. The inverse this time is just f inverse of x. And the original function is f. So this is the equation of the tangent line of f inverse of x. This is in point slope form. So I know a point and a slope on my inverse right now, don't I? What is the point that I have from this point slope equation? 1, 4. And f inverse of 1 is the slope 1/3. Okay? So what would be the point that correlates on the original function? 4, 1. And look, they want me to find the equation at x equals 4. So that's convenient because that's this point, right? So we have the point. We need the slope.
3.
F prime of 4, very good, would be the reciprocal of this one, so 3. But on this problem, they want us to write the equation of the tangent line on the original function. So our answer is the point slope equation. Y minus equals, very good. That's the answer we're looking for on this problem. Do y'all have any questions? All right, let's flip over to the back.
It was y negative 1 equals 3. Yeah, I got it.
You got it?
Yeah, I got it.
Okay. So on number 10, it says, write the equation of the line tangent to f inverse of x at x equals 4, given f of 3 equals 4 and f prime of 3 equals a. All right, inverse function. I am given f of 3 equals 4, so that's a point on the original function. The coordinates being
3.
great. So f prime of 3 is equal to a. So on the inverse, I switch the x and the y for the point, so I'll have 4, then 3. And then I need to know what f inverse prime of 4 equals. 1 over a. Very good. The reciprocal of the derivative of the original function. Now I have to write the equation of the tangent line on the inverse. So it'll be y minus the y coordinate here, 3, equals the slope, 1 over a, times x minus 4. And that's the answer. Questions?
So we don't even need to solve for A?
No. You can't. They don't give you enough information. All right, number 11. This one is based on a table. It says, given that g of x is a monotonic increasing function. So monotonic would be another way of saying it's a one-to-one function. So it could pass both a vertical and a horizontal line test. So they're just saying that so that you know for sure that taking inverses is okay. All right? Find g inverse prime of negative 4 based on the table below and show how you arrived at your answer. So the inverse function is g inverse. The original function for this problem, whoops, I tried to write function and g at the same time, so it turned into fung. Function is g. So, I want to find g inverse prime of negative 4. So what does that tell me about the point on the inverse? The x value is negative 4, which means on the original g function, y value is negative 4. Now we have a table of g of x, right? Do you see negative 4 as the y on the g of x table? Okay, so what x belongs with it? 2 is the x that goes with the y of negative 4 on g. So on the inverse, Negative 4 is the x when the y is 2. So now I need to know what g prime of 2 equals. I can get that out of the table as well, can't I? G prime of 2, g prime of x for x of 2 gives me 3. So what is g inverse prime of negative 4? 1/3. Yes, the reciprocal. Any questions? We good? All right. Number 12. This one is based on a graph. Given the graph of f prime of x below. So this graph tells us the derivatives of the f function. And the fact that f inverse of 2 equals 1. Find f inverse prime of 2. All right, so I'm going to set it up. The inverse is f inverse, and the original function is f. I have a point, f inverse of 2 is 1. That's a point on the inverse function. The coordinates are 2, 1. Good. So on the original function, the corresponding point would be 1, 2. So I'm going to need to find f prime of 1. They give me a graph of f prime. So I look at the graph. When x is 1, and this is my x-axis, this is my y-axis, so here's the origin. When x is 1, what is the value of f prime of x? 4. 1, 2, 3, 4. The graph is up here at 4 then. So f prime of 1 is 4. We got that off the graph. So f inverse prime of 2 would be 1/4. Questions? All right. The next 5 examples, we're switching gears altogether. We have new note cards in this box that you're going to need to add to your stack of note cards and memorize. Okay? There are 6 of them, one for each of the 6 inverse trig functions. Okay? The derivative of inverse sine and derivative of inverse cosine are almost exactly the same, except for the derivative of the inverse cosine is negative. 1 over the square root of 1 minus x squared. Okay? The derivative of inverse tangent of x and the derivative of inverse cotangent of x are almost exactly the same, except for the inverse cotangent of x has a negative derivative, 1 over 1 plus x squared. And then the derivative of the inverse secant of x and the derivative of the inverse cosecant of x are almost exactly the same, except for the one for the inverse cosecant is negative. 1 over the absolute value of x times the square root of x squared minus 1. Now, I will tell you, occasionally on these bottom ones, you might see it without the absolute value bars around the x, especially in problems that involve context where x couldn't be negative anyways. So just be aware, if you see the absolute value bars missing, that doesn't mean that you're not looking at the derivative of the inverse secant of x. Okay? Usually they're there, but occasionally they're not. So notice each of the ones that starts with c. Inverse cosine, inverse cotangent, inverse cosecant, those are the ones that are negative. All right, the others are the positives. So really, if you can just memorize the 3 and then know which ones are negative, should simplify that studying process a little. So we're going to use those 6 new note cards to find derivatives over here. The first one says y is equal to e to the x times the inverse secant of x. So this is a problem where we'd have to use the product rule to take the derivative, right? So y prime or dy dx, I guess I probably should have written dy dx since that's what it says to find, but they mean the same thing, equals, I'm going to copy the first function, e to the x, and multiply it by the derivative of the inverse secant of x, which is this bottom left note card. 1 over the absolute value of x times the square root of x squared minus 1. Plus, copy the second function and multiply it by the derivative of the first. The derivative of e to the x is e to the x. And we're done. Any questions? All right, number 14. On this one, we're going to have to use the chain rule to find the derivative. The outside function is the square root, but to use the power rule, I probably want to think of it as 1/2 power. Y equals inverse cotangent of x raised to the 1/2 power. So when I find y prime, I'm going to bring that 1/2 power down in front. I'm going to copy the inside function, subtract 1 from the old power, so that's going to give me negative 1/2, and then multiply the whole thing times the derivative of the inside function. Is this derivative going to be positive or negative? Negative, because it starts with a c. Negative 1 over 1 plus x squared. And we're done. Very important that this is in parentheses, though, because we're multiplying by a negative, not subtracting. Okay? Any questions? All right. Number 15. On this one, we have to find f prime of negative square root of 2 over 2. So there's an added step. First, we find the derivative, then we plug this in for x and get a number for our answer. Okay? So first, f prime of x equals. Oh, they've got arc cosine here. What is arc cosine? Inverse cosine. So every single one of these with the negative 1 on them can also be written as arc and then that trig function. Arc sine, arc tangent, arc secant. This is actually the old-fashioned way of doing it. They started doing the negative 1s more after the calculators came around. When they used to do it with tables of values, they used to have arcs in front of them instead of the little negative 1. They mean the exact same thing, though. Some textbooks favor one way or the other more. They use both on the AP exam, so you need to know both. So 1/2 arc cosine of x will be 1/2 times the derivative of the arc cosine, which is the same thing as inverse cosine, negative 1 over the square root of 1 minus x squared. So I found the derivative, and I would be done if it was like the two previous problems, but now I have to substitute the negative square root of 2 over 2 in for the x, right there. So f prime of negative square root of 2 over 2 will equal 1/2 times negative 1 over the square root of 1 minus, in parentheses, negative square root of 2 over 2 quantity squared. Okay, let's see if we can do some arithmetic now. When you square a fraction, you square the top and the bottom. So this is going to equal 1/2 times negative 1 over the square root of 1 minus 2 over 4, which is going to simplify to 1/2. So then this is 1/2 times negative 1 over the square root of 1/2. And when I take the square root of 1/2, I do the square root of the top and the square root of the bottom, so it's going to be 1 over the square root of 2. Right? Did I lose anybody there?
Isn't it 1 minus?
1 minus a half is a half. Right?
Oh, yeah.
And the square root of 1/2. I'm taking the square root of the top and the square root of the bottom. So the square root of the top is 1 and the square root of the bottom is square root of 2. Are we clear on that? All right, so now when I'm dividing by a fraction, I multiply by the reciprocal, right?
Yes.
So 1/2 times -1 times square root of 2 over 1. Negative square root of 2 over 2. Oops. Yep, sorry. We doing okay? All right, number 16. Find y prime. The outside function is inverse sine. So I'm going to take the derivative of the inverse sine, which is 1 over the square root of 1 minus x squared. But in the place of the x, I'm going to copy the inside function, 1 over x, quantity squared. And then I'm going to multiply the whole thing times the derivative of the inside function. But to take the derivative of 1 over x, I probably should think of it as x to the -1 power. So I can use the power rule. So the -1 is going to come out in front, then the x, subtract 1 from the power, -2. Questions? All right. Well, this is not a product of two functions. This is a composition of functions. The inverse sine is the outside function, and the 1 over x is the inside function. If it was inverse sine with another x there, then you would have to use the product rule because there'd be two functions.
Wait, so are we done?
We're done with 16. We're going on to 17 though. Y is equal to the arctangent of x cubed. Find y prime. So this is another chain rule problem. I start by taking the derivative of the outside function arctangent of x. What is the derivative of arctangent of x?
1 over 1 plus x squared.
That's right, 1 over 1 plus x squared. But in place of the x, I'm going to fill in the inside function. So it's x cubed squared. And then I have to multiply the whole thing times the derivative of the inside function, which is 3x squared. Any questions?
We can simplify x cubed to x cubed squared to x subset, right?
No, when you raise a power to a power, you multiply the powers. So that would be x to the 6th there, if you were to further simplify it. And that could go on the top if you multiplied them. Any other questions?
If it was x squared times x cubed, it would be x cubed.
That's correct. Any other questions? All right. All right.